Good morning. Welcome back to Open Med School. The last session we had discussed about the heart sounds. Today I'll be discussing about the murmurs. What are murmurs? Murmurs are produced due to turbulence of blood inside the heart. So this is a series of vibrations of various duration, usually heard with a stethoscope over the chest. Now let us look into how will you classify murmurs. Basically, murmurs are divided into, depending upon the cardiac cycle, into systolic murmurs and diastolic murmurs. When it occurs in the systole, it is systolic murmur, and when it is in the diastole, it is called diastolic murmur. That is a basic classification. Sometimes the same murmur may be heard in systole and diastole. That is called a continuous murmur. So this is how you classify the murmur. So as we know, the first heart sound or S1 is produced due to the closure of the mitral and tricuspid valve when the ventricle contracts or during systole. And the second heart sound occurs during the diastasis when the blood tries to go back to the ventricles. The aortic and pulmonic valve closes, that produces the second heart sound, usually represented as two lines. And again at the end of diastole, the ventricle contracts and the cycle repeats. So if it is heard after the first heart sound and the second heart sound, it is a systolic murmur, and it is after the second sound, it is diastolic murmur. The same murmur that is heard starts in systole and passes through second heart sound into diastole. This is what is called a continuous murmur. So basically, murmurs are divided into systolic murmur, diastolic murmur, and continuous murmur. Now we look into the systolic murmur in a little more detail. So what are the mechanisms of systolic murmur? So systolic murmurs are divided into, when it is seen throughout or heard throughout the systole, it is called a pansystolic murmur. So the murmur starts with the first heart sound and ends with the second heart sound. You may not be even identify the first sound. That is the pansystolic murmur. So how can you get a pansystolic murmur? Suppose you think there is a defect in the septum, ventricular septum. What will happen when the ventricle contracts? From the very beginning, from the left ventricle, the blood goes to the right ventricle, and it continues till the systole is over. Because as you know, the pressure inside the left ventricle is much greater than that of the right ventricle from the very beginning. So you may not be able to even identify the first heart sound. So murmur will be that is starts with S1, ends with S2. So classical example is the ventricular septal defect. Think about, suppose the patient has got a mitral valve is incompetent. Again, the LA pressure is much lower than that of the ventricle. So what happens, the valve is not competent, not closing properly, the blood will be leaking from the left ventricle to the left atrium during systole from the very beginning. So again you will get a pansystolic murmur. So the same thing can occur in tricuspid valve. So three diseases you should remember. One is the mitral regurgitation, second is the tricuspid regurgitation, third is the ventricular septal defect, where you get a pansystolic murmur. So hope you understood what is the mechanism of the pansystolic murmur. Second type of murmur is called, so write the pansystolic. Sometimes it is called holosystolic murmur because it is heard throughout the, so it is called a holosystolic also. Now think about, suppose the aortic valve is narrow. So the narrow aortic valve is called aortic stenosis. So what will happen? So look at the picture. In aortic stenosis, so think that the aortic valve is narrow. This is the aortic valve is narrow. So what this is the pulmonary artery, or the pulmonary valve is narrow. Both situations the same type of murmur occurs. So the left ventricle, when starts contracting, it produces the first heart sound. At that time, what happens? The mitral valve is open, is closed, aortic valve is closed, pulmonic valve is closed. Everyone, the pressure starts mounting. Once the pressure is above that of the left ventricular pressure is greater than that of the aortic pressure or pulmonary valve pressure, the valve opens. So there is a small interval from the first heart sound to the beginning of the ejection of blood into the aorta and pulmonary artery. And this period is called the isovolumetric contraction period. So the murmur starts, suppose the valve is narrow, as we have already mentioned, a murmur can occur when the excess blood passes through the normal valve or blood is passing through an abnormal valve. So here the valve is abnormal. So what happens? It produces turbulence and produces a murmur. So the murmur starts after some time, that is after isovolumetric contraction. It peaks because the ventricular contraction produces more force. There's a rapid ejection phase followed by slow ejection. So the murmur goes to a peak, then it comes down. So it is called a crescendo-decrescendo murmur. So the murmur is a diamond-shaped murmur. This sort of murmur is characteristic of ejection of blood into aorta or pulmonary artery, and so it is called a ejection systolic murmur. So when you say ejection systolic murmur, the murmur arises from either the aortic valve or the pulmonic valve. That is the point to remember, and this you can clearly hear the first sound. There is a small gap, then gets the murmur and ends well before the second heart sound. So which are the conditions where you get ejection systolic murmur? Two important conditions. One is the aortic valve, from the aortic valve, and second from the pulmonic valve. So classical conditions are aortic stenosis and pulmonary stenosis. So now we understood that two types of systolic murmurs. Now we go to the third type, it's called a late systolic murmur. Late systolic murmur is classically seen in mitral valve prolapse. So that is seen in mitral valve prolapse. So what is happening in mitral valve prolapse? So you will draw the picture of the heart. In mitral valve prolapse, there is excess or redundant tissue for the mitral valve. So when the ventricle contracts, initially the valve closes. So during systole, the valve closes. Then as the pressure mounts, the valve flops. There is a leakage of blood occurring into the left atrium. So this initial, so in the beginning there is no, so the closure of the mitral valve produces the first heart sound. Then there is no murmur. At the later part of systole, when the valve opens, it produces a murmur, and the shape will be something like this. So it starts with a clicking sound because the excess or redundant tissue in the mitral valve, when it opens, it produces a clicking sound. So it is called a click murmur syndrome. So the other name for the mitral valve prolapse producing the late systolic murmur, it is called a click murmur syndrome. And this click is not due to ejection of blood. So it is called a non-ejection click. So ejection occurs only to the aorta or pulmonary. So here the ejection there is no ejection. So it is called a click murmur syndrome of mitral. So there is a non-ejection click followed by a murmur, and the murmur is late. So it is called a late systolic murmur. So the three important types of murmurs systole are pansystolic or holosystolic, ejection systolic, late systolic. There is one more systolic murmur. They are the early systolic murmur. They start with the first heart sound, usually a decrescendo murmur, ends before the middle of systole and never extend to the second heart sound. So the same conditions that produce pansystolic or holosystolic murmur, that is VST, MR and TR, can produce a early systolic murmur, sometimes called short regurgitant murmurs. So in the next session, we will discuss on that diastolic murmurs. So when you are describing the murmur, you have to go by the location, systolic, diastolic, pitch of the murmur, character of the murmur, where is best heard, whether it changes with the respiration or any other maneuvers. We will then discuss about the description in another session. Hope it was useful. Thank you.